this last video, we'll take a look at some of the most difficult examples of u-substitution. There are times when you try to do the matching up and it just doesn't quite fit, but it's close. And in these instances, it's usually an extra variable that's to blame. So I'll show you how to handle that. Begin by identifying your u, which we'll take to be the quantity under the radical. And my du then, take the derivative of u, and it's 2 dx. Now, as always, I'm going to clear that constant to the other side, make it 1/2 du equals dx. Now, when I begin to match things up to see how I'm doing, my u appears here. I can match this dx with this dx, but then notice, in addition to the radical being there, which is okay, that's a function I can integrate, I have an x sitting here that's extra. What we do in that instance is you're going to take your u equation and solve it for x. So I'm going to take u equals 2x plus 1. I'm going to subtract the 1 to the other side. I get u minus 1 equals 2x. And I finish by dividing that by 2. So I get x equals u minus 1 over 2. By solving for x, I've now given myself an additional substitution possibility. I will begin by writing my integral as an equivalent integral with the fractional exponent before performing my u-substitution. Now when I match up the parts, the 2x plus 1 matches the 2x plus 1. dx, I also have a substitution for. And now I have a substitution for x, which puts it in terms of u. So I'm going to replace all of these parts to form the u integral. Begin with the yellow. So I have u to the 1/2 power. Now the purple x I'm going to replace with u minus 1 over 2. Keep my integral symbol, and then the dx I replace with a 1/2 du. So hopefully you can see how things ended up falling into place. My 2x plus 1 became my u, my dx became the 1/2 du, and my x became my u minus 1 over 2. So all the pieces have been substituted for. In order to begin working on this integral, which still looks a little complicated, first of all, I've got an extra constant of 1/2 tucked in there. I could factor a 1/2 out of that purple fraction and just be left with the numerator u minus 1 as its own term. That would allow me to then pull this constant out in front. 1/2 times 1/2 is a 1/4. So now I'm left with a nicer looking version where I've gotten rid of my denominators, so that makes me a little bit happier. And the last step before I actually integrate is I will distribute this u to the 1/2 power to both terms. So I've got 1/4 the integral. Now this is u to the first power. When you're multiplying expressions with the same base of u, you add the exponent. So I'm going to add 1/2 to get 1/2, also known as 3 over 2, minus u to the 1/2 times 1, u to the 1/2. Now I'm ready to integrate. So back up here, I'm going to go ahead and write this with my 1/4 constant. Then u to the 3 over 2, I'm going to add 1. So it's going to become u to the 5 over 2. Put the reciprocal in front. Minus, I'm going to add 1 to 1 over 2, and it becomes 3 over 2. Put the 2/3 in front, and then of course we'll have the plus c. I would distribute the 1/4 into both terms, so that makes it 2/20 u to the 5 over 2 minus 1/4 times 2/3 is 2/12 u to the 3/2. Reduce my fractions. I've got 1/10 u to the 5/2 minus 1/6 u to the 3/2. And since we were given a radical to begin with, I'm not going to let this stay as a fractional exponent. So this will become 1/10 of the square root of u to the 5th power minus 1/6 square root of u cubed. And the last step, of course, is to get rid of the u's and go back to having x's. So my final replacement takes me to 1/10 2x plus 1 to the 5th minus 1/6 square root 2x plus 1 cubed plus c. Fun. Let's take a look at one more example. This one again has sort of a wrinkle to it. In this situation, you do have parentheses that kind of makes you believe, okay, that's probably going to be my u, but when you get fractions, sometimes you really have to get creative. So if at first your u doesn't seem helpful, go back and try a different u. So I'm going to have u be my x squared plus 3. My du would be 2x, constant goes to 0, dx. And again, I'm going to automatically boot my constant to the other side, so I have a half du is x dx. All right, now when I start to match things up, my u is here. My dx, I have an x dx. Okay, well, the dx matches. But then notice I have an x where I really want an x cubed. So that's a little bit of a problem. Again, it turns out the easiest way to take care of that situation is going to be using the original u sub and solving it. Here's why. We know that x cubed is really the same as x times x squared. It's x times x times x. I can keep two of them bundled together. Now, how is that helpful? Again, go back to matching. My x squared plus 3 is my u. Good. My x dx now has a full match. The only thing that's sticking out right now is I have an extra x squared. What I can do is I can go back to my original u and solve it for x squared. So if I take u equals x squared plus 3 and subtract that 3 to the other side, I get a statement that tells me what x squared is equal to in terms of u. So now, when I'm looking at my integral, this purple x squared part can be replaced by something in terms of u. So I'm going to be able to swap out all the pieces and replace them with something in terms of u. So let's do that. To begin writing my u integral, my u is on the bottom here of the fraction, so I'm going to keep that here, u to the 5th. My x dx is the half du, so that goes here. And the last part, my purple x squared, is here. It's u minus 3. And again, I'll do the color coding just to show you how everything ended up. This is the purple. This is the yellow, and half du is the blue. So the only thing left is a 5th power. Now it's in the bottom of a fraction, which is a slightly new wrinkle, but not difficult to deal with. Here's how. What we're going to do is we're going to keep the 1/2 in front, integral. So when you have a binomial in your numerator and a monomial denominator, you can split that up. So I'm going to make two fractions. I'm going to put u over u to the 5th, and I'm going to put 3 over u to the 5th. Here, when you have things divided that have the same base, you can subtract their exponents. So u to the 1st divided by u to the 5th ends up being u to the negative 4th. Here, I have a 3 over u to the 5th. Well, the way that the exponent rule works, in case you don't remember, if you have a u to a negative exponent, that's the same as 1 over that same u to a positive exponent. So what I'm looking at in the case of 3 over u to the fifth is kind of going in reverse. If you have a positive exponent down here, you can make it a negative exponent, and whatever your numerator was is just a coefficient on that. So I can rewrite 3 over u to the fifth as 3u to the negative fifth. And the whole reason I wanted to go with these negative exponents is negative exponents, you can use the power rule, same as always, to get your antiderivative. You do need to be careful though, because remember, if you take and add 1 to negative 4, students will commonly say that that's negative 5. It's not. If you take negative 4 and you add 1, it becomes a negative 3. So you're going to have u to the negative 3 divided by negative 3 minus, we have a 3. U, when you add 1, this becomes negative 4 divided by negative 4. And of course, the plus c. Now, once you've finished that step, all that's left is to actually clean it up and simplify. It's some algebra, which is not to say it doesn't get tricky, but it is only algebra at that point, not calculus. So to begin the cleanup process, I'm going to go ahead and distribute my 1/2 in right away. So I'm going to have u to the negative third over 2 times negative 3 is negative 6. I have a minus sign. Now I'm going to distribute the 1/2 again, which will become 3u to the negative fourth over negative 8. I don't like this minus a minus business, so I'm going to take care of that. I'm going to leave this one with a negative 6 on the bottom. I'm going to make this one a plus 3u to the negative fourth over 8. And just as before, we didn't have negative exponents. We introduced them to make this easier to work with. So at the end, we usually do pop them back out. If you want to make the exponent positive again, you just move it back to the bottom part of the fraction. The numerator, there's nothing left, so it becomes a 1. The negative 6 was down there to begin with. We just bring down the u cubed. It becomes positive once it drops. Here I've got a 3 in the numerator. That will stay. The u to the negative fourth will drop, and when it does, it becomes positive, and it will stay next to the 8. And then once you've done that, you're ready to kick your x back in there, giving us a final answer of 1 over negative 6 times the quantity x squared plus 3 cubed plus 3 over 8 times the quantity x squared plus 3 to the fourth plus our constant.